Good morning and welcome to the data structures class. So, thank you for selecting this subject. Those who have registered for the subjects, I welcome you all. We will start with a data structure. Here you know the prerequisite something is mentioned in your course, that is the introduction to C programming. So, but to deliver this course I have to introduce little bit about the machine on top of which I am going to discuss the data structure. So, for me the basic understanding of the machine architecture is must to deliver the data structure. So, here is goes the basic course description. What we are aiming for? We are aiming for developing a problem solving ability and algorithmic thinking. In the process, I will explain you what is exactly algorithmic thinking when we try to solve the real world problem. So, as mentioned, as I have discussed, the introduction programming is one of the prerequisite, basic knowledge of programming language, choice is yours, C, C++, Java. In your curricula, you people are got enough opportunity, I mean one semester and the lab work to get yourself competent in C language. So, my assumption is that you are good in C language, may not be the master. So, we start with the course objective. So, if I go to the course objective 1, so to understand and apply the concept of, I can say, the different data structures to solve the problem. Which problem? It is a real world problem. I mean when we are facing a problem on reality, I want to plan a mesh schedule, so that the waiting time of a individual who is taking meal can be minimized. Can I solve this problem? If I try to solve this problem using machine, what I have to do, how I have to model, how I can select a appropriate data structure. Okay. So, course objective number 2, implement, analyze the different type of data structure for software application, utilize and apply again the data structure like graph structure and algorithm for solving the complex problems. Maybe I have to enroute a message from a particular user or a machine through my institute gateway to the outer world. And then the course objective 4, employ a hash table for different data storage and retrieval. We have many applications starting from the spell checking, starting from designing a storage, starting from storing the data to the secondary memory, where the faster retrieval is possible through the hashing. Then analyze the time and space complexity. These are the two metrics by using which we can compare whether my solution is better in comparison to the previous solution which is proposed, or I am proposing a solution, I want to quantify, I want to attach a attribute to that solution in terms of the space and time. Here the space means the storage, it can be in main memory or secondary memory. That is the reason in my course I will be covering in a nutshell the main memory and secondary memory before we move to the actual content of the data structure. So, coming to the next, this is the course what we plan to complete. We start with introduction of the data structure, and where I will cover the bit of the machine organization, main memory organization and secondary memory organization. Then we will discuss on the time complexity and the space complexity, asymptotic notation, and some examples followed by that. Those are mostly from the C language, how you are going to calculate the time complexity and the space complexity. Then first data structure what we are going to introduce, that is the array, then the string. Next followed by the linked list, stack and queue. While dealing with the stack and queue, we are going to implement, or we will discuss the algorithm development with the help of array as well as the linked list. That is the reason the linked list has to be covered ahead of the stack and queue. Then comes your nonlinear data structure like tree and graph. Then final one is the hashing. So, then we have another variants of tree which is called heap, and we have various type of heaps, but looking into the semester constant and timing constant, we would like to discuss only few heap structures, but in the nutshell you will be getting an introduction to the different type of heap that are used in real world problems, so that you can have an insight that if required you can you can think of applying the different type of heap structures to your problem, so that you can have a efficient solution or efficient algorithm for that. And that followed by the sorting algorithm, and we will try to discuss internal sortings and external sortings, and sometimes we are going for a analysis of internal sorting algorithms to give a view how the internal sorting algorithms behaves with different inputs. I mean, a random input, a pre-sorted input, a semi-sorted input, is like that, and simultaneously we will go for a implementation in the lab to have a actual picture how it behaves, how a particular sort behaves. Then the last one is some case studies where you have to apply your knowledge of the data structure to design a solution. This has two parts. Either you can design a solution, or you can implement with help of a programming language. So, for this my preference will be Java. I will explain you that why we are going to do it with a Java. Maybe looking into our curricula, you got the opportunity to learn the C, and this is the semester you have to do with the Java, and when we will come to the algorithm and others in the next semester, we will be doing with C++. Okay. And the assessment is as usual, the quiz and assignment 20%, midterm 30%, and final grade is 50%. That is your end sem exam. Then because of the NBA and other requirements, we have the course outcomes. That is the reason we have stated the course outcomes, so that we can take the feedback at the end of the course and we try to analyze whether we are meeting the course outcomes. Usually it is a 5 and 7 in number, so I have listed in my material the 7 outcomes. As I am disseminating the material to you over the MS team, you can go through the details and you get a picture of that, what is exactly called a course outcome. So, learning and application emphasis, mostly we try to develop a skill with you, that is for practical application, problem solving skills, and when we are going to deal with complicated problems, we are talking of analytical skills. I am developing an algorithm using a specific data structure. Before implementing with help of a programming language, I want to state my claim that my solution which I am proposed is with better complexity, it takes the very less space. So, that is possible through the analytical skill, and which is sometimes bit of theoretical work, lot of mathematical derivations, and those things can be again tested when you try to implement that with help of a programming language. So, the course details, if you look into this, so introduction to data structure followed by the abstract data type, which tells about how logically I am going to represent a data structure, either it is proposed or developed by other scientists which we are going to study, or if required I am going to propose a new data structure. Then in the introduction section I am going to discuss the machine architecture and the memory, because we define the data structure is representation and the set of operation that can take place in the main memory. So, that is why the memory organization is must. Little bit of CPU architecture is required, because few data structures are good for multi-core and others. Then without going through the details, we will talk about in the nutshell about the memory management, and the last one the data structure alignment and the padding, so that we will have a realistic feeling that when I am dealing with a data structure, I am very close to the machine. I am going to work with the machine, because when I am designing a solution, I have to translate my algorithm with help of a programming language, and it has to be implemented with help of a machine. With evolution of the machine, it is a challenge for us whether I am able to utilize the power of the machine, because unless and until I represent my problem in machine, I am not going to apply the algorithm. Further, we are going to discuss the complexity analysis, that is time complexity and space complexity. I will have a little bit introduction to amortized analysis and Kolmogov's complexity. Okay. Maybe those things we are not applying to the data structures what we are studying now. Now, role of the data structure in algorithm, here we try to study through a case study how a particular solution to the problem leads to the development of different algorithm, or you can say the different solutions when I am changing the representation with different data structure. What I mean to say, if I am storing in a linear array then I can design an algorithm as per that. If I am storing them to a binomial heap or a Fibonacci heap or a binary heap, my algorithms will be different. For this, we will discuss a case study finding the kth largest element in a linear array. Okay. Now, then as I say, the real world application, we have many real world application which will be given you as a assignment, and we will be discussing one or two where we are expecting you to participate in design. I mean, you are suggesting that this data structure is appropriate, followed by your argument. Okay. It is not that you are going to write down immediately algorithm and implement it. Only things, read the problem statement, suggest your idea that this data structure is better, followed by the complexity. When you are going to represent in a data structure, sometimes the complexity of the algorithm which is going to be work on that data structure is bounded by a constraint or bounded by the way it is represented. I mean, if there are n things are there, I can say it is a n items I have to check. Maybe it will be too early to say that if I am introducing a complexity notation, as some people are able to use that at the early stage, people say big O notation. So, it is something like that. Huh? So, we will be introducing those things in details. So, now this is one of the problem which just I am introducing without any background. So, read this. This is one of the example where we try to say how I am going to apply a data structure to solve this problem. If you read it, a social media platform often suggests new friends to the user based on their existing connection, implementing an effective friend recommendation system. So, in general we talk about a recommendation system. The objective to design a system that analyze the user connection, how a user is connected to its friends and maybe further label, and they suggest the potential friend based on the mutual connection and the interest, and you asked to design a solution to that. Your objective is to suggest who are to be your friend, which you are facing every day if you are using any social media site or like a Facebook and others. So, and sometimes this is also applicable to the research community or various research community website like ResearchGate and others. So, now what is the solution? Without going through the details, without arguing that why this data structure is used, the first one, it is suggested that we are going to use the graph and hash table, then the priority queue. So, now without knowing the details of the data structure, you can say a real world problem, and this gives you just an introduction that to have a feel that we need to learn data structure when we try to find out the solution to the real world problem with help of the computer. Now, when it comes to the implementation step, so what is the implementation steps? So, how we are going to implement it? Again, it depends on your skill or your competency on the particular language. As I have mentioned, there are different programming languages based on your expertise, whether you are a very good C programmer or C++ or Java programmer, whether you are a power user or you want to develop, write down the utility of your own. What I mean the power user, the modern languages are rich in data structure. There are the library, there are the class files where you need to take the help of those things to design your solution. What I exactly try to say, suppose you want to use a hash table, a data structure, then if you are using the utility class of the Java, you no need of writing the basic codes. Maybe you are trying to do a operation on a data structure stack, you do not have to write down the code for insertion, deletion and the display of the content of the stack. So, if you try to go for the C language, then you have to write down all the codes. Okay. So, depending on your expertise, the implementation takes the shape and how you are going to code it. So, I have other 2 or 3 applications which is available to you over the Microsoft Teams. So, I do not want to discuss those things, I am skipping those things and I am directly coming to the problem solving process. Okay. So, as I say, we are aiming to develop the skill how to solve a problem with help of the data structure. So, in problem solving process, first we need to define the problem. So, here are the famous codes. If I had an hour to solve a problem, I would spend 55 minutes thinking about the problem. and 5 minutes thinking about the solution. So, when a large amount of time is spent on thinking about a problem, so this is the process through which I try to abstract the problem and I try to represent on the top of the machine, and then maybe I am selecting a right programming language to design a solution, then so that the implementation will be easy for me or I will able to meet the objective. So, now you look into the simple problem solving process with help of a computer. A problem is there, we will go for a solution if solution exists. Assume that a solution exists. So, the process is the problem, we solve the problem to get the solution. How we are solving the problem here? We are solving the problem with help of a computer or a machine. So, what we try to do? We have a problem, then you look into this. For the problem, we have a representation. I have to represent the problem in computer, in particular in computer memory, in general in the main memory of the computer, and that representation is possible with the help of the data structure. Once it is represent, now something called the compute. This is the algorithm which you code it using any high level language, compile to get the code which executed on the top of the machine or executable code. So, that produces a output. This output is nothing but the solution. So, a representation is must and a data structure is coming to the rescue. So, again it is another way of defining the problem solving process. So, this is the act of defining a problem. How you are defining a problem? A person comes with a problem, he narrated his problem, but when you try to model it problem, you say yes, this problem can be represented as a graph. Graph is a data structure. As a designer, you are able to map the real world problem can be better represented in a graph. And if you are conversant with the different algorithms or which is traditionally taught in any course, maybe those algorithms are good enough to find out the solution. If not, you are designing new algorithms. Okay. So, the cycle is like this: defining a problem, generate the new idea, that is in terms of algorithm after representation, evaluate the selected solutions. I can give you one example. When you are defining a problem and you try to represent in the machine, you are selecting one data structure DS1, another data structure DS2, because this data structure is facilitate or restrict you how you are going to design a solution. So, we have two solutions, that is algorithm 1 and algorithm 2, and then what I can do, which one is the best? I will take the help of a programming language, I will try to code these two algorithms with help of that language, and I am going to evaluate the solution or the outcome, and if one is best, I will accept, or if I observe that some fine tuning is required, I will go for that. Okay. So, maybe for a small number of input, one algorithm is good, and that is just a data structure DS1, and for another a large number of input, this DS2 representation is found to be better. So, I have to use the algorithm 2. So, these are the insights one has to learn looking into real world problem. Keeping all the data structures in mind, one has to think or one has to design a solution. So, this is what will be my last slide before we introduce formally to the data structure class. So, we have a real world problem which I was mentioning, then formulation of abstract problem, and once you formulate the abstract problem, you are able to represent that. So, before solving, this requires a representation where your data structure is coming to picture, and based on the representation you are going to design the algorithm. So, solve the abstract problem with help of the machine, then you analyze the solution whether the solution is acceptable to you or not, and if solution is acceptable to you, you are going for the implementation. I mean, you are put that into use, so that the real world problem will be solved. And if you go further in the problem solving process, if you are implementing a solution for a period of time, you may analyze the performance of your solution. Let us say I am talking of some system where throughput is concerned to me, and I am using a particular algorithm to enroute the masses in a local area network or a LAN, or you can say roughly in an internet environment, let us say, without going in details. But I found that 80% users are happy with the response time. I am using algorithm in the back end and 80% users are happy. And based on the feedback, I am now being asked to design a solution so that more than 80% customer or more than 80% user will be satisfied. So, what I am going to do? Am I going to think a new algorithm, or I can go one step backward? I may try to think for a new data structure. Maybe I am the person who is going to propose a different data structure, so that my problem will be represented using that new data structure, and I am going to get a satisfaction or the throughput of my system more than 80%, maybe I can say 90%. So, it is a continuous process. Even if we design a appropriate data structure or we select a appropriate data structure, design a solution, but depending on the requirement, depending on the change of scenario, this becomes a continuous process. That is the reason data structures are evolving, new data structures are proposed. Sometimes the new architecture is going to facilitate, or it is a constant to us. So, programming language, they try to include the basic operations of the data structure to their library, so that you can design a faster solution. So, with this we will be moving to the basic portions of the data structure. So, thank you for your patience hearing. So, we will be continuing with the basic data structure, starting from the definition of data structure to the machine architecture. Thank you.